Thank you. Aaron is with us from, it's very well-known name from across the entire world. She is from Canada, Ireland, British, Switzerland, UAE as well, and she knows ecosystem. And I am very impressed from her profile and working, and always see her each every post and her comments, and learn a lot. And last time I learned that. We the leaf enters are the micro water molecules transmitters to our environment, and how the balance is. And this you farm water and cultivate in soil, like I was the tagline on your on your end.
Yeah,
Awesome.
it's plant water
Yeah, yeah, yeah.
because I think water is one of these drivers behind the entire system. We have the hydraulic cycle, we have the soil cycle, and you almost can't separate one from the other.
Yeah, awesome, awesome. And I always practicing, and we that water is beer life. Water is a carrier. Water carries life. Water carries no religion, no boundary. It's on the planet. We all are one. We have a single atmosphere, ecosystem, and the oceans. We are well connected. We have to take care of it, and always want to listen your ideas and how you think. Like we were talking that some voices are that the human needs more technology, more innovation than degradation. So we have more tools, and like AI we are very much depending on, but I still say that the real intelligence is there. As a human use the AI, artificial intelligence, to come up with many more resilient solutions what we need. And we are talking about the PFAS, the food contamination. We are talking about microplastic challenges. Like in our coastal line, there is no life. We need more shrimp, prawns, fish, and we need algae in our oceans for the respirations and other things. So please tell more about the soil and water nexus, and the humans need food, and food safety and security as well. Yeah.
Okay, great. So I wanted to just talk a little bit about extreme weather because I think extreme weather is something that we're having to deal with more and more. And generally, there are four types. We can talk about extreme heat, we can talk about extreme cold, we can talk about extreme precipitation or storm events, and we can talk about drought because they all kind of tie in together. Drought and flood, of course, are two sides of the same coin, which is starting to become a little more common knowledge, which is great because it's really important that we don't think of them as being separate ideas. They really are interconnected. Part of that reason, for instance, is if you look just at the surface, you have plant leaves and litter, which actually it absorbs a lot of the energy from raindrops when they fall, which means that you don't have the compaction of the soil. And that's really important. Of course, it also helps to keep the soils cool. It helps to build up the soil organic matter, which then holds water. And I mean, it's actually an incredible reservoir of water. I think an underappreciated one. Um, Depending on who you ask, a 1% increase in soil organic matter, it also depends a little bit on the soil type that you're dealing with. It can hold somewhere between 200,000 or 350,000 liters of water per hectare. It's an enormous way of keeping water within the first 30 centimeters of the soil. And this isn't something that we think about when we plow up the soils and we leave them completely bare, right? The farmers do that as a matter of course, and then they wonder why all the topsoil washes away and why their soils dry out and why we end up with floods. But one of the other things that the soil does is it holds a whole bunch of plants surfaces on which grow the bacteria, fungi, and the volatile organic compounds, which is what we were talking about earlier, what you had mentioned before, Abdul, about the biology that happens to be existing
Yes.
on the surfaces. So one of the reasons that those are really important is because those compounds can get blown into the air, swept up into the atmosphere, and because they're biological, they have some proteins on them that can cause water to freeze. And when it freezes, it's freezing at a lower temperature. You get turned around a little bit backwards because remember you're into the negatives. You're at zero on the
Mm.
surface of the planet, we get water freezing, but when you're high up in the atmosphere, pure water is freezing at about minus 38 degrees centigrade. So
Oh,
so so that's really, really high in the atmosphere, right?
yeah.
But if we can freeze water closer to -2 or -4, that means that it's much, much lower in the
Yes.
atmosphere. It's closer to the surface of the earth.
Yeah.
And when that happens, it means that it's going to create clouds and it's going to rain in a much more local area. So you get the creation of rain and the rainfall cycling much faster. It's local. It's not being
Hmm.
sent all the way up to the higher levels at the stratosphere and raining
Hmm.
somewhere completely different as the world is turning all the time. So that's a huge point. We'll get back to that in a minute. But then you look at what's happening below ground as
Yeah.
well, okay? Because remember, we're talking about drought and flood. So below ground, you have the roots that are opening up compacted land or
Hmm.
land that is really super hard. That's when you get the really deep tap roots, for instance, in some of the desert plants where they're going down 30 meters in what seems to be almost pure rock. I mean, of course, it's not
Hmm.
necessarily pure rock, but there's not a lot there, and it's able to access the water from far below and create shade, of course. So it's keeping the soil surface cool. It's when it's opening up the soil like that, the roots are also allowing water to infiltrate from the surface down to recharge the groundwater.
Aquifer. Yeah.
Yeah. And then on top of that, you're also supplying the water necessary for the microbes to be able to function. You have them cycling nutrients to feed the plants, and you're keeping these organisms alive and allowing them to develop because you're keeping water within the system. So when you have a lot of micro and macro fauna, like mites and like
Hmm.
worms and like nematodes and all these things, you're actually opening up the pore space. And when that pore space is opened and you have areas within the soil that can hold water and that can hold air, you're changing the environment in which these organisms can live, and you're actually favoring organisms that are helpful and healthy for plants to grow. So you're moving along the succession lines and you're allowing the development of a more diverse and a more interesting, if you like, terrain on which you can grow crops.
And I have a question. When we were
Hmm.
young, we see earthworms and we see a lot of small insects and going inside soil and coming outside. Maybe that time the soil was porous, but now we do not
Hmm.
see in our local land like earthworms or the odor, the beautiful odor and the rainfall of the soil. It looks like a nature, yeah.
Yeah.
But
So when you
unfortunately,
have a lot when you have a lot of organisms that are in your soil, then generally speaking, you have a high level of biodiversity. And for the most part, those will be very productive, good microorganisms. But if we till the land, so if we use a plow or we use chemicals, of course, those organisms lose their homes, they get chopped up, they get killed by the chemicals or by the salts of synthetic fertilizers, and the entire base of the food chain dies. And those microbes are actually the microbes that are responsible for feeding your plants. So of course, as those start to die out and the numbers go down and down, farmers become more and more reliant on the synthetic nutrients to keep cycling, which you end up in this loop of having to apply more fertilizer for lower yields because the plants are sick and they can't feed themselves anymore because we've destroyed the soils. So I would agree with you that in many places, because we've had 70 years of synthetic fertilizers and all types of
Yeah.
pesticides, we've lost those natural insects. But we can bring them back. And this is what we're trying to do. We're trying to cultivate wild spaces and have areas of land where we're not having any sort of pesticides or any sort of fertilizers added, but we're using agroecological principles. And in fact, Pakistan and India are super good about that. They're really almost taking the lead in some respects on moving the food production system towards that type of production, which for me is wonderful. I'm so excited to see this because they can show the rest of the world that this is the way to go. So
Yeah.
and then rebuild the healthy ecosystem, which is amazing, right?
After talking to you, I
Um,
always say that water carries life. Water gives life. Water is not a V-shaped molecules, but it's a carrier. It carries electrolyte. It runs in your body. So today, after talking you, it looks like soil is a living thing. Soil
absolutely.
is like a ecosystem. When more you study, more you get in depth. Water and how the soil and how we contaminated it with synthetic chemicals or fertilizers or pesticide. I still know some conventional farmer. They use just the sulfur uh, smoke and normal smoke to flies for that, and never are very habitual of a lot of pesticides and killing the insects, which were integral part of our ecosystem, the natural ecosystem.
Well, this is what happens. We throw the ecosystem out of balance because we look at something and say, "Oh, there's a pest there. We have to kill it." And when we do that, we reset
Hmm.
the entire system because we kill much more than just the one pest. We kill the 99% of the good guys that are there as well.
Hmm.
And then when there's nothing left to protect the plants and the system is out of balance, then we start to get really bad fungal infections and attacks from all
Yes.
sorts of insects because the plants they've lost their natural armor, which is the bacteria and the fungi and all these microbes that can protect the plants um, through the spraying of the chemicals, which is really sad because the chemicals are super expensive.
Yes.
And, we don't understand that even if we add a little bit, we're ending up disrupting the whole system. So a better way to look at it is to say, okay, what is a predator on that pest that I'm experiencing? And if you look from a more holistic standpoint, you can say, okay, for instance, that pest would be normally attacked by a predatory wasp. What do I need to plant in order to have a nice home for predatory wasps so they come and they live on my farm? And
Hmm.
so you might decide, okay, I'm going to plant some papaya trees because the
Yeah.
papaya trees will then attract
Yes.
the predators to the pests, and then you've cleaned up the problem without throwing the entire system off kilter. So
Yeah.
it's really really important. But then there are other things that we're doing that are also making a big problem for our system, and that's our land management.
Hmm.
So if you look at some places like southern Spain, what we've done is we've cut down a lot of nature, a lot of the trees, the farms, instead of being open fields, we've covered them in greenhouses. And what we've done there is we've changed the albedo and we've changed the land use so that everywhere there are just these translucent polyethylene panels that are letting light in, but they're not actually contributing to the natural cycle of agriculture, right? So you've got China, Spain, Japan, Korea, Turkey, which are accounting for about 90% of these global greenhouse coverages of the land. And 95% of that is plastic, which is a nightmare on another scale.
Yes.
But the thing is, in even just in Spain, you have about 250 kilometers squared of greenhouses in this one little town, and in the very southern tip of Spain. And it only takes about 100 kilometers squared to change the weather. So
Wow.
you have an enormous size simply because we're not thinking of the repercussions of changing such a large area and the albedo of it. And we just think economically this is a good place to put more greenhouses. So we really have to start to think about what it is that we're doing. I'll give you another example of how we're disrupting the small water cycle. That's with the deforestation. A lot of places in Europe, in North America, they go and they spray the forests to get rid of moths or to get rid
Mm.
of other insects. They do sprays of mosquitoes, pesticides, just widely. And we haven't learned that that actually doesn't get rid of the problem. What that does is that kills the birds, which then aren't around anymore to be able to eat the mosquitoes. So we get disease, we get all sorts of things because we're not thinking of the holistic system.
Yeah.
So and we were talking about the evapotranspiration, about the microbes that are on top of the leaves, right? So yes, they're protecting the plants, and yes, they're going up and creating rain, but they're
Yes.
doing more than that, because what they're actually also doing through the evapotranspiration cycle, which is when the plant's roots are taking the water up, they're breathing out water
Mm.
vapor.
Yeah.
Okay, and when that happens, you have the lowering of the temperature around the tree or around the group of trees or around the forest, which then lowers the pressure. And so as you have lower pressure, you have wind that's rushing in. And that wind is pulling moist air inland so that you actually are generating rain far away from large water bodies, because you just have this the
Yes.
evapotranspiration
Yes.
happening.
Yes.
So that's critical, right?
Yeah.
Like that is one of the most important cycles in
And then
nature that we
I
have.
I observed this. I live in Lahore. It's in
Mhm.
India-Pakistan border, and as you said that the 100 kilometer in southern Spain, the plantation just changed the climate. We observed here in 4 to 5 years back that dry wind phenomena, and you
Mhm.
have your cheeks are dry and the bleeding from those, because what I understand, when there is no moisture balance in atmosphere, you can't respirate. You need moisture to keep your respiratory tract moisture. So uh, there is no high-rise buildings are here and trees are not. So humans are too much. When I 40 years back, 35 years back, when I came in the city for my education in the government college, it's a very old British time college, and you see, and it's like you recall the memory of London city and the Texas. So at that time, a lot of rains were there. Every after 3 days, 4 days, if it's a sunny day and it's rain, but now the pattern is entirely changed. And after experiencing driving, we realized the importance of human to plant ratio. That more humans are here, we need more plants. We need so
Mhm.
micro
But
transpiration.
there are simple solutions to that. For instance, putting on a green roof, or having green spaces within the city that can absorb floodwaters right? But that can otherwise be parks and have lots of green growing. It's a function of the government understanding the importance and doing preventative work in order to make sure that there's enough water soaking into the ground, enough space for the soil to act as a sponge and to take in water when there happens to be a lot of flooding. Now, of course, I understand that there are places within Pakistan that are having tremendous difficulty with these floodings, but there are steps that we can take to slightly mitigate
Yeah,
how bad this flooding is. And unfortunately, throughout the world, we're not doing this.
yes,
But we should be, because this is not going to be a 100-year event. This is going to be happening, every couple of years. So we better prepare for it.
yeah,
And I think green roofs is a really great way to do that.
yeah.
So because you change everything, and you create an environment that's nicer to live in.
Yeah, I had a podcast discussion with Chris in Alberta, and that was the water energy nexus. And he highlighted the thing, and which I convinced that every steps, every human steps, or every steps, whatever you are going, the people, organizations, even the economists thinks what will be the payback period, what will be the return on investment. So this is whenever we talk on the culture, on the infrastructure upgradation, like we are getting older now. So the idea is fantastic. The green rooftop, and we need to address on serious grounds like the flood comes, and a lot of human, and I see the animals, the cows are dying, and the buffaloes and goats are other living organisms. So this is a very good idea, and we'll try to do with some if we can. I also do the working with the federal government on the pipe. We'll try to pass on this idea if they can. They're interested to do it, and to safeguard, and it's the climate resilience. Rather to just call it a climate crisis, but we can do this. What individual or what on the mass level can be safeguard. So this is very true, and I have noted your points and really
It's
agree with this.
it's unfortunate that we do have a tendency to look at the payback period, because
Yeah.
I think things are changing so quickly that actually those numbers will be meaningless. Because if we
Yes.
keep having disaster after disaster after disaster, it's it's on an unprecedented scale, and things are changing so rapidly that what has happened, what was reflected in the last 50 years, is not reflected today. So really, we should be trying to preempt these problems and save ourselves a lot of money by dealing with the issues now and trying to mitigate so that the damage isn't as great. And in that way, we're spending, yes, a huge sum of money, but so much less than we would be if we have to clean up. They
Yes.
always say
Exactly.
an ounce of prevention is worth a pound of cure, right? And this is
Mm.
absolutely case in point that it's worth spending the money now, regardless of what the payback period is, because the payback period will only realize when we actually have the next catastrophe and it's not as bad as we think it is. So, or as
Exactly.
bad as it could be. So that's yeah, that's an interesting discussion.
Yeah. Very true. And I'm very grateful to you. Whenever speak to you, time is always flying, and there's a limited time, and people want to listen to you more and more. When I talk about myself, and whenever we invite you, it's always huge learning. Whenever we speak with the technocrats, the knowledgeable people, you seems that you are still on the ocean, on the side, and a deep knowledge seas are ahead. And this is the learning. And if I can pass on this to save 2,000, 5,000, or 10,000 people, my life is satisfied that I have saved that life. Last time I had a podcast with the Ukraine vice president of water, how they create water management things and equipment, and still they exports and this. And going to talk on Thursday on Japanese water experts, and everywhere across the planet, they are the galaxy and the beauty and how to restore our planet and how to restore our things. And we have passed about our life, and the new human and the coming and the custodian of the in this marathon has to take this planet and life ahead. So after hundred and thousands of years, like uh, Adam's era and Christ and the pre-Christ and the time zone we reach here after 2,000 years, and still in curiosity that the development, but not is this sustainable development we need. We need our planet back to us, the nature. When I was here, we have seen small sparrows, but after the construction and no trees, the sparrows are nowhere. So we, after seeing this, and now sometimes we see in television or internet, then we see that they were our companion, our partner on the planet. We miss them. So always have a great learning. So thank you, Aaron. Thank you very much. And we'll have another session sometimes. And in the panel discussion, we'll call you. And take care. And bye-bye for now.
Super.
Thank you.
Thank
Yeah,
you, Abdul.
thank you.